This training video will give a little tour of the Design Pad Template command. And the very title of the tutorial is drawn on the screen here as an aside by use of the command draw by example. So by picking the LXX text, we capture the size, font, and color and layer of that entity, and the program launches into the draw text command. So draw by example is a useful way to duplicate something you already see on the drawing. But that was by way of an aside on that notion. Let's focus on Design Pad Template. Go to the Surface pull down and you'll find it about midway down, Design Pad Template. But before doing so, you need to design to a drawn polyline. We're going to do the rectangle command. It's an AutoCAD command to get a simple rectangle drawn. We'll zoom in a little bit and go to Surface, Design Pad Template. Now, we're going to design with respect to a surface file, and at the bottom of the dialog, specifically in Release 2012 and going forward, we've made whether or not we write out a revised final surface a setting in the dialog itself. So you can be prompted, not do it, or automatically write a final surface. Let's get prompted. Take the prompt option. And note our other settings. We're going to design by ratio and even draw slope direction arrows as solid cut arrows for clear distinction of the direction of slope graphically. Select OK. Pick the pre-drawn pad polyline. Now from this pad polyline, which we're going to place quite deep, 20 feet deep at 1990 elevation, it will go outward in an external direction to find the existing ground for this pit per our settings. We'll pick the pad, select the tin. We'll use a 3:1 slope in this example. Default the arrow size to 5 and put the pad elevation down at 1990. There it goes in the outward direction with a 238,000 cubic yard volume involved. We'll hit exit. Adjust parameters, no. Here it is. We've asked for this prompt. Write the final surface to the triangulation file. Yes. Merge pad with target surface. Yes. And we can give it a new name. So I'll call it example 2A as I evolve this site and replace it. And you can see if we go to the 3D viewer window, I'll carefully crossing select the elements, that we have, especially if we exaggerate it, a nice deep pit drawn here with 3:1 slopes all the way around. And in plan view, you'll notice we have these slope direction arrows indicating the downward nature of the slope into the pit. Okay, now we have our remnant 0 elevation perimeter, which I'm going to choose to erase. That's usually the top item. I'm going to get rid of it there. I got rid of the wrong one. I want the green one. So if I briefly freeze layer, I'll erase that black perimeter at 0 elevation and then thaw layer and bring back what I want here. I want to illustrate another command. This is I have Drawing Inspector on, and this is the 2012 elevation. What if we drew, using our Draw 3D Poly command, a 3D polyline? We have a few of the prompts turned on. We'll draw on the layer DTM. From the nearest snap, picking up elevation 2012, and coming down into, using the nearest snap, the base of the pit right about here, and it defaults to 1990, which is correct. And there's our 3D poly drawn. Notice if we inspect it, you can see the elevation real time along it heading down to 1990 and heading up to, actually it's 2012. Now if we right click, you can actually get polyline data reported, including the slope. So if I turn that on within Drawing Inspector, notice that the slope of this is 6.61%. It turns out to be that, given the distance of the line, and that's actually a drivable slope. So this is a workable ramp, if you will. We can right click again and turn off the slope in Drawing Inspector for now. In fact, we can go up to Drawing Inspector, click it again and turn it off as we continue to work. Now we can go to a very useful command under Edit. That's 3D Poly Utilities, Offset 3D Poly. Let's make that ramp 20 feet wide. We'll go to Offset 3D Poly, Interval, 20 feet, no vertical, and make the other side of the ramp. Now we don't have a pad. We have two distinct 3D polys. But you can use Edit, Join Nearest, and this middle option, Directly Connect Endpoints, is perfect for connecting two 3D polylines opposite each other. We tolerate a maximum separation of 21 feet. That means anything less than 21, join. We know they're only 20 feet apart. They will join by Direct Connect. We hit OK. And crossing Select and join both ends up. Now we have our merged tin, including the pit. Let's do a sort of iterative process and build a ramp into the pit by that same command, Design Pad Template. We go to Design Pad Template, keep all of our selections the same, pick our new pad, done by a very common combination of Draw 3D Poly, Offset 3D Poly, Join Nearest. We pick that pad, use example 2A in this iterative process, and we'll do the same 3:1 slopes, same arrow size, and there's our new pad drawn in, smaller amount of cut, 7,400 cubic yards, roughly. Adjust parameters, no. Right final surface, yes, that was that prompt from the initial dialog that we want. Merge it in, and call this example 2B. Working through the iterative process. And in this case, we did not cut off the existing first exercise, the first pad. We didn't trim, and it's advisable to trim, but you can always trim after the fact. So if I go Edit, Trim, we can select that trimming perimeter and then pick on these various lines and remove them from the original work. And just like that, let's get this bit of the perimeter trimmed out. And then if we get rid of some of the little slope direction arrows, we accomplish the same thing. I'm going to do one more trim and trim to that perimeter this remnant piece right here. Let's view this in 3D and see if we can clearly see the ramp entering this pit. And yes, it's very clear. Goes into the pit. Slope direction arrows help in the visualization of this process. And you even get the precise calculation of an interesting edge where one design contacts another, and that could be staked in the field. And you can create points using Draw Locate Points. I would point that out by going to the COGO menu and doing Survey, Draw Locate Points. Actually, it's under the Points pull down, which is in actually all menus. And I can screen pick using a nearest snap anywhere I want on this. And it gets the default elevation, description, and new point number drawn wherever you might pick. So with that done, let's do a more complex road entering our pit. We can draw a 3D poly, or actually a 2D poly, that starts on a particular elevation. Let's start at 2000. We'll sort of angle to the right and then arc our way so we're sort of facing into the pit roughly perpendicular. And then we're still in the polyline command. If you do L for line and a second L, you come off perpendicular. And then you come off radial, I should say, or tangent to that arc. And let's pick our way into the base of the pit and hit enter. Now, this polyline has no elevation, but we have a nice 3D command under the 3D data called 2D to 3D by start end elevation. We know the start's 2000 and the end is 1990, so let's use that command to have an even slope polyline along the way. 2D to 3D by start end elevation, one of many ways to construct a 3D polyline. So we select our polyline, give it a start at 2000, give it an end at 1990, and we're done. If we go back to the drawing inspector, we'll notice that the elevation is interpolated along the way, approaching 1990 at the end. We can repeat the same kind of process we did earlier using the offset command. We can go to Edit, 3D Poly Utilities, Offset 3D Poly, offset 20 feet, no vertical, and offset this polyline northward, followed by Join Nearest. It's a nice pairing of offset 3D poly followed by Join Nearest, tolerating as much as a 21 separation. And why do we put a number in there? In case you picked a lot of things, you don't want their beginning line to connect to their end line if they're 150 feet apart. You don't want to get confused. You want it to join only the closer portions of the lines selected. That's why you sort of filter this Join Nearest function by a max separation to join. Use the Direct Connect endpoints, hit OK, and select these two entities and their ends join nicely. Now we repeat the design pad template command. Going into this command, we hit OK, select this single pad, react to our second tin in this iterative process, use our 3-to-1 slopes for now, our slope direction arrows, and we obtain 14,000 cubic yards of cut, no fill. Adjust parameters? No. Right final surface? If you want to keep iterating, yes. Merge. And the final surface would be example 2C. Save. And that is merged in. Again, in the original dialog under pad template, we don't have the auto trim feature turned on. So we're not trimming, that's a prompt, trimming the contours out. That's used to be at the command line. It's now added to the dialog in release 2012 and going forward. So we'll make a note of that. But we can quickly go through the trimming process after the fact using that trim perimeter and selecting the pieces from the original design as shown there. And then we can also erase some of the remnant slope direction arrows and pretty much result in the final look. Let's verify it in the 3D viewer window. Come in and select a few of the original contours and our various ramps, and you can see how this looks versus the original ramp that we did. And you get the idea how this process is iterative. So if you were to go to Drawing or Surface Inspector and then selected your latest final tin, comparing it to the original, you'll note in areas outside the pad they are equal, 2005.05 in both cases. You get into any of your pad work and one is lower than the other, as you can see here. That is a very common way to conduct your work through iterations of your pad template design. Now let's quickly go to another example. If we window out and go to this example here, we have two perimeters with known elevations. Now let's make these 3D polylines. Right now, if we do a command list elevation and pick these pads, they're at 0, both of them. One quick way to change their elevation is to do pad polyline by interior text found under 3D data in the civil module. And you can come in here and say, we'll keep the original polylines and we won't do any offsetting and we won't add any elevation to the pads, because the full elevation is provided in the text. It doesn't say 27.6, it says 927.6. And we'll hit OK. Set layer sample for elevation text. Set layer sample for boundary line work. We'll hit Enter for no more. Then we'll crossing select or individually select the items involved. And they've been elevated. You could do this for the entire site just as easily in the same amount of time. Now, if you go to List Elevation under Inquiry, you'll see that the elevations of the pad were raised. And we'll repeat it for the pad 17, 927, just to illustrate the command. Select OK. One selection here, one selection here, no others. And pick the ones you want to do this to. You can actually pick any number you want at this point, and all of those get raised. Now what we want to illustrate here is that you can do multiple pads at the same time. Note that these are going to be in fill, because if we go to Drawing Inspector, your elevations locally are 926, and that is lower than the associated or nearby pads. So now, turn Drawing Inspector off. We'll go back to the pad template command, but we'll select the multiple pad option. We go into Design Pad Template, and there's an option to process multiple pad polylines. We can look at the setup. We're going to go by ratio. There's various options here, but we're just going to use selection-based multiple pads. We hit OK, and we'll select our target surface, which is the original ground of bid grading plan. We'll look for that, original tin. Open it up, and we'll select our two pad polylines. Now they're going to have to bump into each other as they're very close to each other at that eastern corner. Arrow size 5, outslope ratios, well, we'll go 2 to 1 in this case, just use the defaults. And you can give different slopes to each distinct pad involved. And we have just a little bit of fill, no cut, as we expected, 277.8 cubic yards. Write final surface file. We don't care about that in this case. But what's happened here, they don't overlap each other. They merge together, and the higher pad, the 927.6, pushed the 927 back, and the merging position is closer to the 927, as would be expected. And this can also be viewed in 3D. We'll just window that little area. And you can see these pads both in a fill condition. Put the exaggeration back to 2. Tie together and merge above the existing grade where they meet each other at the intersections. Very useful command to do multiple pads at one time. Now we'll go to a third quick example. We'll load the civil demo drawing. In this case, just to give a heads up, we have a 3D road that was drawn by RoadNet, or Road Network command, including a 3D polyline pipe drawn by the Sewer Network command. And you can see the pipe at the end. See the detail there of that shoulder and the side slope at the intersections done by Road Network. And the pipe at the end hits a low point at the back corner of our cul-de-sac. Now what we're going to do here is show you the drainage area into that corner. So if I double click into our hydrology module and go, in this case, upstream or downstream to the original position and drop into the drainage tab of this cul-de-sac inlet, let's review the drainage that goes into it. So if you select calc, and there's a 10 involved that's very accurate, it'll calculate the drainage area feeding into that inlet. And when we do this, it illustrates a little bit of a problem. We have some flow, illustrated by this green flow line, flowing off of the site, flowing away from our project onto adjoining properties. So let's say your goal was to drain more of this cul-de-sac region, including lot 85, into that same inlet. Now you can do this with, believe it or not, the pad template command in combination with use of draw 3D poly. Now let's show the techniques in doing that. What you would do is situate a swale between lots 85 and 86 that maybe stays out of the undisturbed tree line here, but draws from about my cursor position into the shoulder area of our cul-de-sac final terrain model. So we go to draw 3D polyline, and here it's very important to use a surface model, the final design surface model, to accomplish this design work. And I'll put it in the layer swale, my polyline. My final surface is Civil Hydro Tin. I will select that, hit open, and you see you get a little inspector wherever you move that's real time. So if I pick a starting position right here, it's at 842.91. Now one little trick when you do this, for really excellent swales in particular, is when you pick, don't accept the elevation of 842.91, but drop it just a little bit. Make sure you get into the ground so that when you offset the other side, it's into the ground as well and you don't get any fill in your swale. So I'm going to go to 842.88. That's 3/8 of an inch almost. Very little dropping, but it's helpful to use that technique. And then what you can do is take it on down into the edge of your shoulder. See, I'm going to go down here at roughly a 3% grade. See how it's negative 0.298%? I'm going to pick a point, and its default elevation is 838.85. I'm going to actually hit P for percent at the command line and make it, rather than negative 2.97, negative 3% slope. And then hit enter for no more. So we have this drawn 3D polyline going into the shoulder area of our cul-de-sac terrain model of the final design. Then what we'll do is the same pattern we've done before. 3D poly utilities, offset 3D polyline. We use the interval method and we'll offset it horizontally. Let's repeat the command. We'll offset it horizontally about 6 feet. Vertically 0. We'll pick and offset to one side. Followed up by join nearest. And they're only 6 feet apart. Tolerate 7. Directly connect the endpoints. And just like that, you've created a swale pad. Now you're back to design pad template. Be sure you turn on write final surface, at least as a prompt, because we want to get a new final surface here. So we go to OK. We use the Civil Hydro tin as our base surface. Pick this pad perimeter. We can give it a arrow size of 5 and use a more mowable slope of 6 to 1 in all directions. Cut slope 6 to 1. And there is our swale. 200 cubic yards, very little. Right final surface, yes, it's very important. And the final surface will be Civil Hydro swale. We'll replace the one we have. Now, going back to the hydrology module, go to the network pull down and make your surface file not Civil Hydro, but the swale version that we just made. So when we double click our way back into the doc dialog and go into the drainage tab and calculate our drainage area, this time the water that runs around into lot 85 and hits that swale should run into our cul-de-sac. So we go to Calc, and now let it react to this new tin surface. It's doing a live calculation with the modified tin that we made. And as you can see, we have prevented water falling on the roof on lot 85 on that building and its driveway from running off site. It finds its way into the swale and increases the flow into our inlet at the back of the cul-de-sac. So these are some of the diverse uses of the pad template command.